What I would like you to explain from your expertise is why. Why do these mRNA COVID vaccines make people more susceptible to infection?
Okay, Will. Well, it makes them more, before I explain, it makes them more susceptible to bad consequences of the infection. So what does that mean? Well, first of all, I would like to make it clear to people that usually when we vaccinate, we do this before we encounter the virus. So I'm always giving the example, if you travel, for example, to a foreign country where there is an infectious disease, and that is endemic, for example, or even there is an epidemic, and we have a vaccine that can protect against that bug, we will make sure that before we travel to that country, we get our full vaccination in place so that by the time we arrive in that country, we are fully vaccinated and protected. So that is not what has happened during the pandemic, because we have started the vaccination during a time where the virus was already circulating. In other words, where people were already exposed to the virus. So let's say I get injected today, I get my first injection. It will take at least 3, 4, 5 weeks before I'm fully protected, or I will be sufficiently protected to deal with the virus in a way that I'm not going to get infected, or I'm not going to get the disease. So when you get exposed to the virus, at a point in time where your immune response is not yet fully mature, that's how we call this. The maturation is the process by which the antibodies are further developing and will ultimately reach full functionality and also a sufficiently high concentration. That takes time. During that time, if you get exposed to the virus before you have reached that status, then of course your immune defense is not complete. It's not fully functional. I'm not saying it's not functional at all, but it's not fully functional. So in other words, it is suboptimal, right? So what happens now when you do mass vaccination, you will, of course, have many people who are sitting on suboptimal antibodies and who get exposed to the virus. And when that happens, there is something very specific that occurs, and we call this viral immune escape. So that means when you have virus replication, automatically you have some mutants, we call them variants, that, accidentally occur, and, stochastically, these mutants can have different characteristics compared to the original strain. So now, some of these mutants, just by coincidence or accidentally, will have properties that make them more resistant to the suboptimal immunity. So in other words, those guys will now, compared to their peers that have not acquired these mutations, they will have what we call a competitive advantage. They will have a fitness advantage. So that means that in this hostile environment of suboptimal immunity, they will thrive better than those who have not acquired those mutations. And therefore, those who have this competitive advantage will start to propagate and to replicate more frequently and better than the others. And that is the way they become dominant in the viral population.
You said that these variants, that these breakthrough variants, they tend to focus on infectiousness because of the spike protein, and that's how it infects the cell. And we saw that through, as you said, through the various variants until we got up to Omicron, which was highly infectious, but it wasn't very virulent. And so that would be my next question. are we at danger of developing something that is virulent, where instead of just being infectious, it's also very, very dangerous, at least to the vaccinated?
Yeah, well, this is now you're taking a big leap, Will, but yeah, the answer is yes. But for me, an answer with yes or no is not meaningful unless there is a solid explanation behind, right? Why it is yes and why it is no. So let's for a second concentrate again on because we are going to come to that answer finally, but let's come just for a second to your first question, which is the difference in the reaction of the immune system of a vaccinated person versus an unvaccinated person.
So what we get within that person who develops a natural immunity is a neutralizing antibody, an antibody that actually kills the virus, and now trains the adaptive immune system to recognize that structure when it hits the body again, even if it's a little bit different, say a variant. And so you have these neutralizing antibodies that are going to protect that person. But because of the injections and the damage that they do to the immune system, and this, as you said, suboptimal antibodies, they do have an immune response, but it's a non-neutralizing immune response.